Hello, everyone. Hey, welcome in. My name is Jason Ostrom. Very excited to have you guys here today, and thanks for attending this. So what I'm going to do really quick is let's keep this light. Let's keep it fun. We have some technical information to share on this course update for Security 598. So we're going to do a quick introduction on the driving forces behind the changes, the catalyst for these changes that Jeroen and I did. And then what we're going to do is talk about what changed, and then we'll do some fun demos. And at the end, we'll have a little Q&A and answer some questions. So let's dive right into it. The driving forces are here. We're going to do a little introduction, Jeroen and myself. And hi, my name is Jason. My background has primarily been a pen tester. I've kind of switched around to other things, but I must be a glutton for pain and punishment because I always come back to pen testing. Jeroen is the original author of this class, and I jumped in to help out a little bit more with offensive security. So Security 598 is a security automation class. And when the generative AI and LM started exploding, Jeroen and I were looking at how can we use AI as a tool to help organizations become better with security automation. So we did a lot of research, and basically this quote down here for me is, we are looking to give students an introduction to practical use cases for AI because the workforce is changing around everything with generative AI and LLMs. So we want to basically have a fun way to for organizations and individuals to take back AI into their companies and use them for practical enterprise use cases where we can make it more deterministic and controlled on the output of the LLM. The second takeaway is our class is really a Purple Team automation framework class. So we really want to help show security engineers and individuals how to take back and use LLMs for automation of Purple Team workflows. So I'm going to go ahead and introduce you over to Jeroen. That's my little take. Now, fun fact about Jeroen, he actually is growing in popularity on his dad jokes and other IT nerd type of jokes. So take it away, Jeroen. Welcome.
I don't know if that's really the fact growing in popularity, but yeah, people probably know me. And yeah, if you had a chance to take a look at the webcast of Eric van Buggenhout, he's actually the father of the dad jokes there as well. So I'm a little bit influenced by Eric, I have to admit. But just also from my side, so together with Jason, we really had an awesome journey related to SEC 598. And one of the key things I was missing, I was playing around a lot with AI, a lot with agentic AI, a lot with LLMs, creating like your local RAG systems. And I always had like a lot of demonstrations, a lot of YouTube information that you can find out there, a lot of blog posts that were there. But what I did find a little bit more complex, and it's also related to my quote there as well, is where it really comes into place if you're going to use it in a production environment or if you're going to use it within your day-to-day operations. So from that perspective, we did a lot of research, a lot of testing. We are also applying it in our current daily activities. And related to that as well, I think one of the most important facts is that, yeah, you have to create a certain environment that is unique for you, where your AI and your LLMs are actually being ingested with your current environment, information about the environment, information about the current statistics there as well. And that's really what we took as one of the key things that we wanted to apply, making it actionable, making it ready actually for you to use into, for example, production scenarios where you can then use automation and AI as well. And I'm pretty proud of what we achieved related to the new course update, but everything is going to be explained in the next slides. And we will also indeed, as Jason mentioned, give you some practical examples and demonstrations on how we are using it these days. So with that being said, welcome all, and yeah, hope you enjoy this webcast.
Thanks, Jeroen. So, hey, everyone, what we're going to do is we're going to walk through Security 598 has 6 sections. We have a day 6 capstone, but section 1 through 5, we changed about 40% of the class, and that's what we're talking about in this webcast. And we added in practical AI and LM and generative AI use cases. and we tried to make it more deterministic using your own corporate data. So we're going to walk through each one of the sections and kind of talk about the changes that we did. So section one here, we have two brand new labs on generative AI and LMs. The lab 1.4 here is a introduction to LM and RAG, retrieval augmented generation. And then we have a building detections lab using LLMs. And this is an enterprise use case with Microsoft Sentinel SOAR. So let's just talk about it, and I'll kind of show inside of our electronic workbook what this looks like. So the first thing to kind of understand is I don't know where exactly you guys are on this, but this is a vital concept to everything we're doing in the class is retrieval augmented generation architecture. And so this is a couple of slides from the class. And the way this works is it gives the LLM, it gives the organization more accuracy and more fresh, up-to-date data, where you're basically hooking in connecting the LLM to get better context on your internal proprietary sensitive data, potentially. So the way it works is you're going to take a knowledge base and you're going to upload your own sensitive data into that knowledge base. And what the RAG does, what the technology does, is it chunks the data into text. So it splits it into chunks, and then it's going to convert those text chunks into a vectorized representation, which is a numerical representation. It uses a model to do that. And then the vector representation is indexed into a special database called a vector database. So that's the initial preparation and synchronization of that RAG knowledge base, which is a vector database. Then, whenever, and let's say some of the data might be your asset inventory, maybe your security architecture, maybe it's pen test reports or red team operation results from that. What you're going to do next is you're going to do a RAG lookup, a semantic search. And basically, what it is it's augmented with your own corporate data on the initial LM inference prompt. So what happens is there's what's called a retriever that retrieves the base data, and the retriever converts your user input prompt into a vector representation. Then the retriever does a semantic similarity search across the knowledge base, the vector database, and it retrieves everything that's similar to the user input prompt. Then your input prompt is augmented with that custom knowledge base, and then it does an LLM inference query using the LLM. And then the idea is it's going to get more accurate results. It's going to eliminate hallucinations of the LLM, and it's even able to enhance because it can do citations of where that data is found within your knowledge base. So there's a lot of advantages to doing RAG, and it also gets around the knowledge cutoff with the base training models. A lot of them are cut off at 2023, 2024. So that's what it looks like. And we have a lot of RAG inside of the class. And this is our first lab 1.4. And we basically introduce a private LLM playground. And we try and have every single lab have a story where you're a security engineer, you're building a purple team automation framework. And right down here, we're going to use Olama. We have a cyber threat intelligence use case where you're going to ingest in threat intelligence into your organization. And you're going to use LLM inference to enhance and augment in certain areas where you want to be able to summarize threat intelligence reports. Also, we have a MITRE ATT&CK framework lab where we ingest in all of MITRE ATT&CK, and then we're able to manipulate that and use that for our own custom use cases. And that goes into the RAG. And in this one, we're doing a local RAG with Chroma database. But eventually in the class, we introduce you guys how to use AWS, how to use Amazon Bedrock with RAG. So we have a lot of different ways and approaches to do this. So that's lab 1.4. The other new lab is detection engineering, writing a detection using LLM. We focus in on Azure Sentinel, and you're able to get a look at how to use GitHub Actions, to use workflows, to how to use the Azure API for automation. And you're automatically creating Sentinel rules, and that's enhanced and augmented with your KQL detection writing automated with the LLM. So we use a lot of different Python SDKs, and that's kind of a look into the first section one. So hopefully that gives you guys an overview of what we're doing here. Okay, Jeroen, I'm going to turn it over to you for section two.
Perfect, thank you. So yeah, based on section one, we also, and I think the original idea behind section two was really like, okay, security, automation, engineering, like, okay, how can we engineer certain things for automation? What are some of the basic toolings? And as Jason already mentioned, we are highlighting a little bit the updates that we gave here. So initially we started with PowerShell, and we started also with a basic introduction of PowerShell, because with PowerShell, you can do a lot of things, especially related to automation, locally on the machines, but also with PowerShell remoting. You can have like a lot of automated tasks or automated activities that are able to, for example, in your incident response phase, that are able to collect certain evidences or even invoke certain actions on end host. So with that being our main objective, also for section two, we said, yeah, look, we can also implement and integrate here some AI related topics. And one of the things we also saw within PowerShell that you now have like automated workflows, so PowerShell workflows, and we really focused more and more on those workflows. The reasoning behind it is, of course, that within those workflows, you can have like, yeah, you can have a more productive environment to actually execute, for example, PowerShell commands in a larger environment. Now, one of the other things that I typically get a lot of questions about when we are working on certain customer related projects is, okay, how can we start and how can you introduce, for example, a standard methodology or a standardized approach related to incident response or analyzing log files? And one of the, I hope you already have some experience or you already have found like information about Jupyter notebooks. But one of those easy things to implement is, for example, at Jupyter Notebooks, and we will have a lot of information in our course related to Jupyter Notebooks, a lot of examples, and we are also within our infrastructure as code environment. We are disclosing certain Jupyter Notebooks there to actually give you hands-on experience on how you can create certain useful Jupyter Notebooks. Now, the reasoning behind those Jupyter notebooks is typically, I get the question like, we are a team of, for example, 5 analysts, and we need to analyze a certain log file if there is a true positive incident created. How can we standardize or how can we create a standard operational model? Well, related to that, from a technical perspective, the Jupyter notebooks, they really give you like an explanation, and you can also include Python code within your Jupyter notebooks to really have like a standardized structure. So all your analysts, all your engineers can actually use those notebooks, adapt them, and based on inputs and outputs, they can actually do additional analysis. We even created an entire new lab related to email threat analysis with Jupyter notebooks, where you have five scenarios related to phishing mails, where you have like a more advanced phishing playbook or a phishing notebook in this case, where you can analyze those emails. So pretty awesome to see that those Jupyter notebooks are being developed more often and also being publicly disclosed at this moment, so you can actually work with them. So that's a very nice new additional section that we created over there. Another one is related to agentic AI engineering. People that have seen previous talks of me, they know the past year and a half, I was working on a tool called Purple Crew, which is a combination of a lot of agentic AIs together. So a lot of agents that are working together. And here as well, there's a certain standard, there are certain best practices, but also challenges that you need to know. And that's actually what we are also incorporated in this section. So the last highlighted section that you see there, agentic AI engineering, is really taking into account, okay, what are some of the standardized workflows that you can use, for example, with agentic AI. To give you an example, human in the loop is one of those things that we also typically apply. but there are much more of those standardized workflows that you can actually reuse over time. And that's what we really wanted to pinpoint within that agentic AI engineering portion or module. If you then see at the next slide, it's not really about yes, indeed. If you see then at the next slide, it's not really about, okay, do we need to go for Gen AI or agentic AI? No, it's actually a combination of both. And that's something we really want to clear out there as well. Like generative AI is one of our focus points, agentic AI as well. And both can be combined. So they are not mutually exclusive. So it's not because you are working with agents that you don't need to think about, okay, how can we implement generative AI within our environment? The main difference there is generative AI is mainly content generation. It has, for example, if you're building like your local retrieval augmented systems, it can definitely create some customized content for your environment where your agents can work with. I always, and this is already like one of the lessons I learned a lot, I always give the example. If you ask an agent to write a detection rule, well, typically, if you're using tools like ChatGPT, and which is more Gen AI in that perspective, but if you're using tools like that, typically they give you a detection rule based on, for example, Sysmon. Now, it could be a perfectly working detection rule, but on the other hand, it could be that in your environment you don't have Sysmon enabled. So with that being said, if your agent then has the context of your data structure within your scene, for example, on how to write detection rules, it can do a much more better job in generating those detection rules. So typically, and that's also there on the last line, AI agents leverage those generative AI models to achieve their tasks. And that's also one of our key focus points within SEC598. How can we integrate both and how can we learn from each other? Like having that context and writing like decent detection rules for our environment. So just to give you a little bit like an example slide of what is being explained here, this is very high level, but it really goes much more in depth than on how to create those agentic AI workflows. And with section 2, which is really about the engineering process, the workflows, I think we also have to look because our Gen AIs and agentic AIs typically also have a connection towards cloud environments, which is then more linked towards section 3. And I think, yeah, Jason, there you also have some nice updates related to our section 3.
Yes, thanks, Jeroen. So we walk through each one of these sections here, and section 3 is our cloud automation section. So an important difference here is in Security 598, we aren't doing an introduction to cloud services like AWS, Azure, GCP. We're really focusing on how you can use the cloud providers to build automations. This class is for builders, security engineers, red and blue team guys that want to, guys and gals that want to basically sit in between those different roles and be able to build things in the cloud. So in this class, we do a lot of things where we're simulating a on-premises system that's using some type of agent that's hooked into the cloud. So it's kind of like hybrid cloud. And we use the power of the cloud, the infinite scalability, to do a lot of automations that way. We have automated threat hunting with like Velociraptor. We have EDR agents where we're doing automated security testing and then measuring the alert, the efficacy of the detection. So this section release here on section 3, we have 2 brand new labs that we're really excited about. And they're down here at the bottom. We have intelligent automation with AWS Bedrock, and we have building offensive agents using Amazon Bedrock and attacking a Kubernetes cluster. So what I'm going to do is really quick, I'm going to show you inside of the electronic workbook what these labs look like, and then talk about them a little bit so you can get a little idea on what we're doing here inside of the new release here. So we have a lab 3.4 called Continuous Security Testing Enhanced with AI. And remember how we brought up about using RAG, and we talked about a local use case where you had Chroma database or Quadrant, and you have your own proprietary knowledge base that's running on premises, right? Well, what about the use case of using the cloud, using Amazon Bedrock, using cloud native to actually store that knowledge base? Because Amazon actually has so many fantastic capabilities and features. If you wanted to build your own generative AI LM solution in the cloud, you could use Amazon Bedrock. And this class shows you how to build that inside of the cloud. So if you're already an AWS customer, I think you're really going to like this. So what we do here is we talk about a use case around vulnerability management and attack surface management. So we have a lot of pen testers and red team guys and gals that come through the class, and they're like, I want to be able to automate setting up a pen test infrastructure. I want to be able to help do ASM, attack surface management. So what we did here is we showed you guys how to augment your Amazon Bedrock with a knowledge base where let's talk about a very specific use case. Let's say there's a risk assessment team and they have an asset management system that has all the information about the inventory of software, asset tagging of all your systems. And you can even add to that security architecture documents. So these can be markdown or text documents, unstructured data. You upload them into your Amazon knowledge base, you synchronize it, and it creates a vector representation. Then when you're doing vulnerability scanning and vulnerability management, you can ask questions using natural language, and use LM inference to ask questions about, there's a Jenkins vulnerability, like which of my systems are exposed to this? And it'll tell you, because it has your whole security architecture, this Jenkins system has a public IP, or it's behind elastic load balancer, it's private, so it's protected. So that's what this lab does. It focuses in on using Amazon knowledge bases for the first time, using the vulnerability management use case. And then at the end, we have some bonus labs where you can set up your own attack surface management system for automated pen testing and internal security testing of your environment. You can even spend a couple extra hours going through that. So this is what it looks like with Amazon knowledge bases. And this is kind of what Jeroen and I are focused on, the concepts, because so much of this is changing so fast. But within our labs, we also keep up with the bleeding edge of the technology changes. And so this is showing you in the screenshot here. This is one of the changes. Amazon has normally doing a knowledge base, it can be cost prohibitive within AWS. And they just released a brand new S3 vectors that's said to be 90% cost decrease. So Jeroen and I are kind of always on the cutting edge of this. And this is a look at the Amazon knowledge bases. And you go into here and we see here that we've set up a vector database with Amazon S3 vectors, which is much more cost effective and scalable. And you can add a lot of data to this and save a lot of money. And this can be a way you can really build a really nice purple teaming automation system using Amazon S3 vectors. So that's a little look into what we're doing here is staying on the concepts, but also being on the bleeding edge of all the cloud providers that are making changes. Now let's talk really quick, Lab 3.5. This is my absolute favorite lab. What we're doing here is we're doing a Kubernetes cluster takedown. We're using infrastructure as code to build your own Kubernetes sandbox playground to do attack reconstruction. And what we're doing here is we're using Amazon Bedrock agents, which the student will manually build these. And then they're going to hook them into MCP and do an exploitation agent. We're using Amazon's API to have different multitask agents build infrastructure and then do QA testing of that security infrastructure using Amazon's API. And then it's a remote penetration testing use case where you're going to talk to the LLM and tell it, do the attack against this Kubernetes cluster, and it's going to automate running through the whole pen test methodology and the workflow. And you can change that, and it uses MCP, Model Context Protocol. And you can make changes to the tools, add in new pen test tools if you want to. But all this stuff is showing you a more deterministic, controlled workflow where we are the experts and we can instruct the LLM multi-collaboration agents on how to carry out the full exploitation methodology. So it automatically sets up a C2 port. And if you wanted to take it further with a command and control, you could extend it in order to do that. So that's what it looks like. It uses Amazon SSM, and it's a really exciting lab. And we're really excited about showing that to you guys. So that's kind of a look at it. And let's go back and see where we are here on this. So this is just an example of a realistic enterprise architecture use case with threat intelligence, ingesting in documents, and being able to use Tines, which is one of the automation tools we feature, in order to help with that automation to chain together Amazon Bedrock knowledge bases using S3, and then automatically extract indicators and IOCs and have those hashes pushed in. And then we can enhance that with natural language and using our own prompts. So this is an architecture of one of the things we look at for the valuable use cases within enterprises. Okay, Jeroen, and then this segues into section 4 with our offensive day.
Yeah, indeed. So our offensive day, which is also the favorite day of Jason, but also for myself and a lot of students are really into how can we automate certain offensive techniques. Maybe just related to the introduction, let me see if I can hold up the expectations of the dad joke. So an SQL statement walked into a bar and it saw some tables. What was the question that SQL statement requested? Anybody? Maybe it's also a little bit too difficult on a webinar, but so may I join you? Join me. So
I was wondering if Bobby Drop Tables was in there, but that's a good one.
So in any case, related to section 4 there, so which was really like the offensive day. It still is, and it will remain also as that. But we updated the content quite a lot related to how we can use AI agents. So you see there, agentic AI frameworks, red team agents, how you can actually create an agent that is able to analyze a certain attack, analyze a certain campaign, and then also go into depth and see with emulation tools how we could emulate and even start the execution of that emulation automatically. So those are some things where we are really focused on autonomous adversaries and AI-powered attacks, where we are now looking and we see more and more tools are being developed. We also have a lot of great examples on related to EDR evasion. And a lot of that information is being able to build like a local, and again, then I'm referring again to the previous sections, but building like a local RAG system where you have, for example, those capabilities built in, where you know on which type of EDR vendor, where you know, for example, which API hooks are not being monitored. That's a potential, how do you say it, blind spot for that EDR tooling. So how you can then circumvent certain things with, for example, the help of AI. So the agentic AI frameworks there as well. We have built a complete new lab related to red team agents, where we are using multiple agents, multiple tasks that are really focused on emulating an adversary in, for example, a tool called Caldera. Now, I want to stress the fact that we are, of course, listing a lot of tools. A lot of things are being mentioned within the course itself. But typically there, what is our initial goal? Well, explain a certain concept, explain already the tools that are out there that you can reuse, but also how you can translate those concepts into, for example, tooling that you are using internally or tooling that you typically prefer there. So with the red team agents, we have developed it within Crew AI, but there are much more AI agentic frameworks that are out there. We have an overview of them. We are also showcasing certain demonstrations during the course with other platforms. So with that being said, I think it's very nice to see that all those tools are out there. Some of them are also publicly available and open source, so you can easily use them. And one of my personal favorites, because I have maybe a little bit of experience with that one, is indeed Crew AI. but it's something that you can easily translate because it has the same concepts. It's something that you can easily translate also towards your own preferred technology landscape. Then as well, a lot of students asked about, okay, what about cloud and cloud adversary emulation? And Jason there as well did an amazing job on how we can do cloud adversary simulation with automated detections, which is a little bit of both. So we are doing offensive on the one hand with dedicated tooling related to cloud resources, but also we are already incorporating some of the defensive techniques. So how can we detect certain attack schemes within those cloud resources? And continuous adversary emulation via CI/CD, so which is really like, okay, the DevOps or detection as code, but also adversary emulation as code. So how can we use those platforms that we learned in section 1 and section 2? How can we reuse them? So as you can see, we are really building up on those concepts, and we are really like trying to guide like the entire storyline of SEC598 is how we can leverage those concepts, integrate them, and use tooling to achieve our goals there from an automation perspective and also from an artificial intelligence perspective. If you then have a look, maybe as an example, what we are explaining within that section is one of the hyper automation tools. So if you see the next slide there. So one of the tools that we are currently not using in our labs, but maybe you recognize the icon there. So it's NAN. It's also one of the tools which I'm going to demonstrate in the first demonstration, where we actually are going to use these kind of automation tools or hyper automation tools, like it's nowadays typically called, where you can easily integrate AI agents, agentic AIs, but where we are going to focus on where are like where are the benefits from using these automation tools, and where do we have the benefits, for example, to integrate it with our agents, also to have that orchestration layer available, and what are some of the advantages of low-code implementations. So how can you use, for example, with prompting, that something is generated for you. But on the other hand, we also have more in-depth examples where you are really, how do you say it, you are in control, and you can then actually execute, for example, with Crew AI. You can really like define the specific tools, the specific needs, the specific, based on your requirements for your security operations center, you can really define it yourselves there. But this is an example, NAN, I will showcase you it, I will showcase it in the first demo. We are using a lot from a lab perspective due to the stability, due to also our experience, and we really like it also in that perspective. We are going to use in our labs a lot of Tines integrations as well. Maybe you heard of it, but it's also an awesome tool you can use from an automation perspective. But don't really focus on the tools we are putting here. Focus more on how can we translate it into words, concepts. Like Jason already mentioned, we are seeing AWS, we are seeing, for example, Tines, but of course we have demonstrations with other tool sets as well. And typically, it's also pretty straightforward on how to translate it into your own tool set there as well. And I see Jason already popped up like the Tines or the TraceCat alternative, which is there as well. Sorry, the TraceCat tool, which is a SOAR, Splunk SOAR or Tines alternative. So again, there we are going to use that kind of tool in the demonstrations. Which is pretty neat to see. I guess Jason, you have a lot of things to tell about TraceCat as well. But from that perspective, same concept. We are trying to guide you in a certain way from a technology perspective, but we also have like a vendor neutral approach where we have like a lot of toolings that we demonstrate, that you want to showcase, that you want to see which kind of capabilities they have towards students or towards your environment. And I think Jason, TraceCut is one of those tools that we are really happy to have onboarded in our course, if I'm not mistaken.
Yeah, thanks, Jeroen. Yeah, I just wanted to take a second to brag and talk about TraceCat. Like Jeroen said, we have several different automation tools. We try to get not too tied up with the individual tool. And one of the things you guys, we got to take this as a grain of salt. Gartner changed away from the SOAR concept to be the hyper automation. So, don't get too tied up in the marketing side of what the name is. We focus in on the security automation tools. One of the nice tools we want to show you guys here, I'm going to do a quick little demonstration. It's called TraceCat. Now, maybe some of you guys haven't heard of TraceCat yet, but these guys are pretty incredible. How fast and rapidly they're rolling out all the capabilities. But TraceCat is how it's a little bit different is they don't have a SaaS they don't have a SaaS hosted model where they host it for you. TraceCat is a free security automation tool that's built for security use cases. And they have a self-hosted model where they create the software and they have a Dockerized implementation if you want to self-host it behind your own on-premises firewall. Or if you wanted to host this in AWS, there's an ECS Fargate runtime Terraform stack where you can automatically spin it up. It's 100% free, and it has a really nice, low code, no code editor. It actually hooks into your own GitHub, so you can have a private GitHub repo where you can have basically your workflows as code integrated in and doing all these customizations, and you can do versioning with GitHub and do a nice GitHub integration there. So check it out, TraceCat. And I want to show you guys a quick demonstration of this. This is a workflow we have in the class with TraceCat. This is a alert enrichment agent. You can hook it into the LLM agent, and it's kind of like doing tool calling to do a alert triage where it's going to look up using API keys of the different virus total and URL lookups. And it's going to automatically look it up, and the LM inference is going to summarize a case. So let's say you're a SOC level 1 agent and you have a case here, and you're going to upload like a malicious VBA macro attachment. You're going to upload it to that, and then you're going to automatically trigger that playbook to run against that particular attachment. Then it's going to take the LM inference, and it's going to do the enrichment across all the different threat intelligence vendors you're using. And the LM is going to automatically summarize that and add notes to the case. So this is a really nice automated efficiency with a SOC where we can do an automated enrichment, and then we can do customizations of this. And then it goes down here and it updates the case comments. This can become a sub playbook of a much larger SOC level 1 triage. We're doing an alert enrichment. So you see here, it steps through and it gives a nice way to debug each one of the actions. And again, this is all free software that you guys can take, bring into your organization. And this is something we talk about how to build these automations using a tool like TraceCat within the class. So Jeroen, did you want to add any note to that? That was just kind of showing a little bit of TraceCat.
No, I think it's excellent. It's an excellent example. And just to add on to the Gartner, how do you say it? Yeah, the Gartner scoring there as well. So indeed, SOAR. So it was in the hype chain, but it's actually now out of the hype chain due to everything that's going on with AI and hyper automation here as well. But I also have to admit that during my professional career, I know a lot of SOAR platforms and a lot of SOAR projects went wrong just by not, how do you say it, enabling your environment for automation and orchestration activities. Until today, I still have a lot of organizations that really have a large benefit of, for example, using automation and orchestration platforms as well. So it depends a little bit on the approach and the knowledge also that you have about those kind of products, but also on what do you want to implement. It's not a magical solution. You need to think about those kind of things. And it's something that I really want to mention as well. It's something where you really need to have like a security process built around or built on top of it, so that you can have that added value related to automation and orchestration. But with that being said, we are going to see indeed that more and more organizations are combining a lot of different things, and hyper automation is now one of the new marketing terms, but it extends a little bit to the SOAR capabilities as well.
Yeah, great, Jeroen. Thanks for commenting on that. So I'll take this on the section 5 and do an overview of it, and then I'm going to send it over to you, Jeroen, because whenever we create these new labs, we like to kind of whoever authored the lab kind of we build it together, obviously, but like this new lab here, Lab 5.4, detection as code test-driven development is goes super in depth, and it's something I don't think you're going to see in a lot of places is exactly how to do this. So let's kind of explore into what it is. This extends the previous lab I mentioned with detection, writing a detection using LM. This is all focused on enterprise use cases using Azure Sentinel, and then using, so basically what it does is that let's say that you use an LM to create a specific detection and it's a specific SIM and it's a specific detection log source, like for example, Sysmon. Once your LM creates that new detection, how do you actually know that that detection is going to be effective in detecting a real event and it's not going to generate a lot of false positives? Enter the test-driven development architecture, and that's what we're doing in this class. And we actually enhance this with an LLM. We basically what we're doing is we're using APIs and we're extending new GitHub Action workflows to have a detection engineer basically have a test-driven development framework using Python, where they're going to generate a detection and then they're going to mirror a production detection role into a sandbox detection environment, and they're able to inject in raw logs based on a specific log source, inject those logs in for a positive test case and a negative test case, and then they're able to measure the efficacy of whether false positives are generated or whether the attack is actually going to be detected before that goes into production. So we're basically doing this just like a software environment. You think about DevOps and how mature software has been for the longest time. We're taking that same paradigm and putting in security operations, layering that on so we can use those same mature models to do test-driven development architectures to more proactively test detections before real events come in. And you can even have LMs automatically running this entire process of creating raw logs, testing positive, testing negative, measuring the detection efficacy before these rules even go into production. So you can set up this automated infrastructure that's always running using agentic AI. So I think that's a good segue into some of these new modern SOC approaches that Jeroen's been kind of deep in this area on blue teams. So Jeroen, I'm going to go ahead and head it over back to you on that next slide here.
Yeah, perfect. Thank you, Jason. Indeed, one of the, I think, Jason, I shared this slide even before it was in the course, but I was working on a lot of questions came in, like from an architectural model. How do you integrate now these new concepts within an architecture? Because a lot of people or a lot of customers were also like, yeah, this is not going to work for me. I don't see the entire picture. So based on that, yeah, we updated the course, and actually everything that is within the course, and correct me if I'm wrong there, Jason, but we managed to get the architectural model into one slide, and this is the example here. Unfortunately, I cannot cover it entirely during this webcast, but this is an example on where to pinpoint certain of those architectural concepts. So, for example, we have a correlated view where your incident analysts, typically they are working on the top layer there. We have case management where they need to be able to hunt, to emulate certain things, doing incident response. But also an important factor, as I already mentioned, an important factor there is human in the loop, having that multi-agent AI capabilities, but still remain in control there as well. So you see, we divided it in different layers related to automation and orchestration, then also the detection toolset, but even with capabilities related to adversary emulation, related to continuous threat exposure management. So those are like, this is the bigger picture on day 5. We are really going to focus, okay, how is this going to work together? And what do you need, and where do you actually need to situate certain concepts that we explained, and how you can bring them together. So I think Jason already mentioned it. That test-driven data is one of the things that a lot of organizations are struggling with, but there are so many tools these days available. If you are working with detection as code, which we have several labs on detection as code, but if you are working with detection as code, then those little gray boxes, architectural boxes that you can see here, within that pipeline are important. How you can implement them, much more detail, again, within the specific detection as code section, within that 5 as well, on how you can then write your detection as code rules, but also how you can then invoke automatically that test-driven data concept where you are going to get results on test data and see, does this detection rule actually work for me? Also, I already mentioned it, giving context towards your LLMs, towards your agents. Well, that's typically also something you do here, because if you see that a certain rule is triggering like 300 times a day, yeah, probably that's not a rule that you want to implement in production. So here it's a little bit like putting it all together. And that's also what day 5 is. And that's also where we are now going to translate what did we do from an offensive perspective, and how can we now create like a modern architecture to actually have those defensive techniques. And I think with that being said, we have like yeah, still some time to let you see on what we are practically doing within SEC598. And with that being said, quickly going to take over the screen from Jason just to showcase yeah, some of our labs, and also to showcase that it's not really a lab and a tooling that we present you, but that you can easily turn it in towards another tool set or another technology. So this is one of our last labs related to creating an adversary emulation and detection playbook, where we typically, in this case, are going to use Times, Lima Charlie as our detection tool set, Caldera for our adversary emulation, and it just like you can already see it, it's a very detailed lab where you have a lot of explanation on how you can write your detections, how do you install immaturely. So I'm not going to go in depth over this entire lab scenario, but I'm just going to showcase to you like, okay, this is what the lab is actually doing, and how did I now translate it in, I think, literally 1 day. How can I upgrade this lab and actually make it work, for example, in a tool which I already mentioned, like NAN. So this is lab 4.5. This is actually Tines. So this is like a Tines tenant that we are using. So as you can see, this is an automation workflow. What are we going to do here? We are actually going to invoke an automation process from a web page that you can easily create in Tines. You submit it, and then the workflow is being executed there. So here you see it being run. So this is now going to take some time, because what is it going to do? Well, it's going to create an adversary profile, so something to emulate. So an attack scenario that you want to try to emulate. It's going to get output, it's going to transform that output for the next step. And here you see an operation, and then also that we have some evidences, and in times, for example, you can use cases where you have, like here, an emulation that is actually going to tell you, these are the techniques I found, these are the techniques that are being executed. And I can really showcase this here. For example, here you have in Caldera those purple team runs. And when you are going to, yeah, let me quickly check one that is going to this one, for example, where you are actually seeing like the execution status of those adversary runs. So this tool, Caldera, open source, freely to use, something we typically use from an adversary emulation perspective, but you have like a full API Swagger file. So here, all those APIs are pretty well documented, and that's what we are using in our lab here. So once again, if we go back towards the last lab that we have, and we go to our stories. So this is the last lab that we have. You see it, we have like HTTP request, HTTP post request, and here you can also, with your story runs, you can actually monitor what's going on. So let's quickly have a look at that story run. It's loading. Thank God for the demos and the internet connection. Let me find another run that was already executed. Oh, now it's not going to do that run anymore, or then I will do it in the event display. That's maybe a better way to showcase what it's doing. So typically you have like your story runs, which is the full run of that specific step. But you can do as well in an event displayer. You see here all the information that is being gathered. And we are focusing again on orchestration and how to implement, for example, all those tools together and how to do that orchestration. And so this is typically based on API calls, on JSON input and output that you are running. So here your request action, create an adversary profile. So there you see then a little bit, okay, what are the abilities that are being used there? So you get some information, some additional information on, for example, this is like a very specific technique that is being used. So this is what you're going to create in one of our final labs, actually in a couple of labs on how you can create such a story and how then also from a detection flow perspective, you can, for example, use Lima Charlie, which is also a very nice tool on how to detect certain aspects there as well. Now, of course, I already mentioned it. I wanted to showcase you that this workflow is not limited to Tines only. So what did I do? Well, I actually used NAN to create a second workflow with AI agents where I'm going to, because NAN, it works with HTTP requests as well, post, get requests there. And it can easily work together again with GitHub. So, but you don't have like a web page ideally that is in here. So here I just created a sample workflow. So I emulated the workflow, but I created some AI agents that are now able to use, for example, in this case, the Open Router chat model. Again, pretty nice feature that or pretty nice to know Open Router, where you are able to select which model you want to use. So it can integrate with Gemini, it can integrate with ChatGPT, it can integrate with any chat model that you want there. And then also you have your Caldera agent in this perspective. So remember, our Tine story worked with HTTP requests related to Caldera. Well, in this case, our Caldera agent is working with those different tools, which is, for example, checking adversary profiles in Caldera, running an operation, creating that adversary profile. So here, if we open it up, you see it again. It's just a small description. And from that description, our agent knows what to do with, for example, that specific API call. So it's a post call. Again, looking at Tines, similar principle. You have HTTP requests. So creating that adversary profile. Here you see it, post requests. And these are JSON payloads that we are using there. So you can easily, let me quickly check it here. So you can easily integrate it, for example, with this new workflow. And in our case, it's like the red team manager and the blue team manager. Now, one of a good question is in our Tines, it's being stored as a case management story. In this case, we are just using memory, combined memory for those two agents to actually know what is being executed and what is actually being triggered as an incident. So this is like a very basic NAN flow on how you can translate our lab 5.5 into like an hyper automation tool with agents, and then actually execute and get a report, which is a very basic report in this perspective, but you can do much more, which is lovable. I don't know if you know it, but it's one of the interfaces I'm going to show immediately. But this is then the outcome where it quickly sees based on what I have run here in Caldera and based on what I've seen from an incident perspective on that host, I am going to match, like for example, certain specifications from the incidents, which could be a technique ID, which could be a certain process, which could be a certain command, based on the information that you are sharing, again, between your red and your blue team, you are actually sharing this over your entire purple team. So with that being said, you are actually then going to create, like in the lab as well, a report on what techniques were executed and what techniques were detection, and then you can rerun it, improve your detections, and that's how it works. From NAN, we can have a look at the executions itself. Again, it's API based, so you connect it immediately with, in this case, it's Microsoft Graph Security OAuth. So it's the OAuth connection that we are using there. And here you see it. You see the incidents coming in, you see the description, and that's actually what you see again here in Sentinel. So, but then it's API based, and it's much more easier because you now have a structured format to compare what you've run from the one hand on Caldera, so here within your execution framework, and on the other hand within Sentinel. How do you invoke that one? And that's something I wanted to mention here as well. So if you don't know Lovable, so actually it's pretty crazy to see, but it's a no-code web interface where you really give it like information. This is what I want to do. And what is it doing here? It's integrated and it's reading my GitHub repo, which is here. So here you see I've created like as code two adversary emulation concepts, which are being documented over here. And based on that, that Lovable interface is actually able to read it. And then you are able, which is then the post request towards NAN, to start that emulation. And then you see it running within your NAN system. And then, of course, you want to have this also in a dynamic version where you then see the results of what was being detected and what was being not detected. Now, I hope that gives you a little bit of sense, like how you can easily translate like a lab you completely did within 598, but then, then actually map it onto like your own technology tool set, which in this case was Defender for Endpoint instead of Lima Charlie. So with that being said, I think, Jason, you also have a nice demo ready for the second demonstration. If there are any questions related to this, let me know. Was really like showcasing how can I get the information that I learned from SEC598 and translate it into my own technology stack. So Jason, I would maybe give the word and the screen back to you so you can actually do the second demonstration.
Now I'm unmuted. Praying to the demo gods here for a good demonstration. But thank you, Jeroen. That was very enlightening to see that. So what I want to do with you guys here is just cap this off to show two quick little demos. One is something brand new that we're working on and we have in the class. And then the second thing is something we've had in the class for a while that's very, very effective: adversary emulation as code concept. So let me take it back to let's go back to what we were talking about with TraceCat. Remember how I showed you with TraceCat? The reason why TraceCat is awesome is because it gets around the data sovereignty issues where you can self-host your own security automation platform. What I did here is I spun it up using Terraform infrastructure as code with my own Amazon Route 53 resource. So you can self-host it that way. And we do that a lot in the class, by the way. While you're doing the labs, you're actually learning infrastructure as code, and we give you a lot of the Terraform templates, so they are perpetual labs. We don't rely as much on the range that's provided to students. We give you guys a lot of these Terraform codes, so you can always run the labs after the class ends. So anyways, back to this. If you look here under the TraceCat, you have a model name of GPT. But what if you wanted to actually self-host your own LLM using something like Ollama? Let me show you something really cool that we've been working on in the class. In this class, we explore the concept of self-hosting your own LLM using a cybersecurity specific trained data set. so you can get advantage of a lot of cybersecurity use cases, and you get around the model guardrails where either the model is changing so fast that it breaks your application, or somehow the model provider has added in some type of guardrail where you're getting blocked from your very specific cybersecurity use case. Let me give you an example. This is Claude right here. And you see here how Claude has a guardrail around specific red team offensive security. Claude is saying, I need to respectfully decline creating this particular notebook conversion because this is a exploit generation notebook that I was trying to convert. Anytime Claude sees code that the user is asking it to convert that code, it has a guardrail, an ethical guardrail, right? But that really doesn't work for us if we're trying to use red team type of simulations in a safe way. Let me introduce you to this. Have any of you guys heard of the Cisco Foundation models? With the Cisco researchers basically they took Meta 3.1, Llama 3.1 foundation model, and they trained it on their own data sets to have a fine-tuned cybersecurity specific model that's a free open weight model that anyone can use. So these model weights are hosted in Hugging Face. Now, here's what we're doing in the class. We are looking at automation where security engineers, as we get more and more knowledge around self-hosting our own LLM that gives us better control for cybersecurity use cases, we can basically take Terraform and automatically self-host our own cybersecurity LLM that gives us a lot of control. So I'm about to release a new open source playground called SageMaker AI Playground, where you can use Amazon's managed service called SageMaker AI. What is SageMaker AI? It's basically a AI managed service that allows you to deploy your own custom models that are hooked into Hugging Face. So what I did here is I use Hugging Face API token to automatically pull in a containerized environment, the Cisco Foundation Instruct model, and now I'm hosting that myself. So this is incredibly powerful for what you guys are doing. Let me show you a visualization of what this looks like. So basically, you're able to use Terraform to automatically spin up your own Amazon SageMaker model, and you're having your own inference endpoint where you can hook in your own custom AI applications where you're using Python code, you're using OpenAI compatible Python code to do an inference endpoint. And then you could even do training of your own data set on top of this. Now, what I'm doing in this demo is I'm going to have SageMaker Jupyter notebooks that automatically get launched. And you'll see here that we have two different Terraform files. We have a model endpoint instance that hosts the model in SageMaker AI. And then we have our own Jupyter notebook that automatically spins up the notebook that's separate from the AI SageMaker. Why do we have that? Because it simulates a realistic enterprise scalable architecture where we're doing the model hosting separate from the actual SageMaker Jupyter notebook. So you can hook in real enterprise applications into this. And the beauty of it is you can spin it up, you can tear it down. It's a little AI playground using Cisco Foundation models. So let me show you a demonstration. I'm converting all of the Cisco AI cookbooks that these Cisco security researchers have released. I'm converting them over to use the SageMaker client. And these are all the different cybersecurity use cases. You can do red team planning, you can do OSINT, and it hooks into your own SageMaker private endpoint for inference. Look at this one here, exploit generation. Right here, we're able to take a known vulnerability description, pass it into the inference prompt of a known vulnerability, and then it's going to generate exploit code for you. And so that's what this is doing. And some models that you use for like the latest OpenAI models, or you're using Gemini or whatever, there might be guardrails, there might be changes. This just gives us a nice environment where we have better control over the model because we can self-host it ourselves. Jeroen and I believe that more and more, and this is what we explore into the class, as more security engineers get more knowledge, they're going to be bringing in and self-hosting their own, because a lot of data sovereignty issues around doing egress API calls out to other models, third-party egress API calls of your own private sensitive data, that can get you into some issues, right? Even if the LM says that they're not using your API calls to do training, still there might be sovereignty issues. And for strict data privacy, you never want to do an egress API call to another cloud model provider, not only counting the control around the quality and the guardrails that those model providers might put in place that might break your cybersecurity use case, or suddenly things stop working. You can use something like this. So I'm about to release this. If you want to follow me, I'll be releasing this soon as an open source Terraform AI playground. Now let's get to the second part of my demo. I just really want to quick show you guys. This is one of our labs. That's one of my favorite labs. It's adversary emulation as code. It's lab 4.5. What we show you guys how to do is to basically set up an adversary emulation as code environment where we have a GitHub action where we have version control and we have a nice GitHub action Python code that sends all of our offensive payload. So we're kind of having a payload as code type of environment where we're able to automatically run TTPs or attack techniques that are chained together that run against our Windows agents that are registered to Caldera. So what it's doing here is the full collaboration of a red team guy who wants to create a new operation in Caldera. It's emulation as code. They create a new GitHub pull request. They submit that pull request. It goes into the GitHub. GitHub will send a post request over to our Tines tenant. Our Tines tenant has what's called a webhook action. The webhook action is like a web application URL, HTTP callback. Then when it hits Tines, Tines translates all of those automated TTPs into code, and it runs over the Caldera API. And then any of the registered Windows agents will receive the instructions to run those automated attack techniques. So we call this adversary emulation as code. And this is a look at the Tines story that does that. This is it right here. And this is a nice Tines story. The GitHub webhook action receives from the GitHub action, it receives the application payload. It will translate and emit for each one of, it goes through the array, and for each one of the array elements, it emits an action to do a HTTP operation over towards our Caldera server. And the Caldera server is controlling the agents and the automated attack techniques run. So this is a very exciting thing. And again, this is something we've been doing in the class that we absolutely love. This is an architecture and a pattern that more and more companies are starting to adopt. And we're happy to have students to come in that like kind of blows them away that this is so cool that we can have offensive actions as code. So the way this looks right here is inside of our private GitHub repository. We have a workflow that's proprietary to students in the class where we can send the operations over to Caldera, and it's sent over to the Tines webhook action. And then we have a GitHub action secret that has some variables that control the sending of that data. And then our orchestrator YAML file has all the different operations. And then that's how we're able to construct those attack techniques. And then inside of the directory, we have each one of the operations that are stored as code. And then you can run the attack techniques that way. So there you have it. We just wanted to explore into some of those, the old and the new, and kind of where we're going, because we're always looking at the bleeding edge and pulling in those concepts into the class. So Jeroen, I'm going to go ahead and turn it over to you. That's the end of my demonstration number 2.
Thank you, Jason. Awesome. So yeah, SEC598, your next advantage. So what it's actually the closing of the webinar there as well. So if you maybe go into the next slide, I think the main essence, and I already repeated myself a little bit during the webinar, but it is really to explain, to demonstrate, like we are showcasing now, to demonstrate, okay, how can you now apply AI? How can you apply a retrieval augmented system? What are some of the best models that you can use out there? How can you make it practically within your organization? from a conceptual model, but also from a technical model, how can you apply it within your own organization? So it's really about demonstrating what is possible. Also, and perhaps you already noticed it, like the with generative AI, a lot of things are changing very rapidly. So that's why we really want to showcase and demonstrate certain things, demonstrate certain concepts, how you can analyze, for example, a certain SOC functionality that you want to implement within your own organization. So we will break down how we are using these tools, how we are actually going to create these capabilities within the course, and then, of course, how you can use it within your own technology stack, as we already showcased with different toolings within the webinar. And I think what I really want to mention there as well, how you can apply these techniques. We were very focused to give you very good in-depth labs. I think even with the first run of our course, like the first version we had, we already had a lot of positive feedbacks related to the labs, like how in-depth and how practical they were. And we really want to build up on top of that. We really want to make it practicable. We also want to make it achievable and also really try to understand how these concepts work from the bottom up so that you can actually explain and transform them within your own technology toolset. So really about the engineering, but also how you can create like that modernized SOC architecture that we showcased in one of our last slides. And with that being said, I think we are almost at the end of our webinar, so we still have some time for questions and answers. I think with that being said, I want to thank you for joining us. Thank you for all the feedback we already received there. From that perspective, I think it's now time, maybe Jason, to go to the Q&A part. Thank you very much.
Yeah, I just added that. Thank you, Jeroen. Thank you, everyone, for attending, and we look forward. We are open to any conversations and continuous feedback for us to get better. So thank you, everyone, and we'll open up to the Q&A. Hayes?
Alrighty, we do have a few questions ready for us here. What level of prior knowledge or experience with AI and machine learning is recommended for someone to get the most out of this course?
Yeah, Jeroen, you want to take that one?
Yeah, perfect. So in that essence, I don't think any experience or previous experience with AI or ML or how, for example, how embeddings work, they are all being introduced in our day one. Of course, probably you need to know a little bit what's out there and how to leverage those kind of things. But there's no real hard requirement related towards AI, related towards ML, machine learning, on how to apply these specifics. We really have like very concrete examples that are focused on cybersecurity and security operations centers. So from that perspective, we do like the introduction there as well in our day one, which go over. We are also not really going in depth in how certain models are being, for example, generated and how certain embeddings, but we do get into the basics on how typically which structure you follow there. And then we really make it practical. Like this is the use case, this is what we need to solve. And we, of course, have our no-code, low-code solutions that will help also in case you don't have, like, for example, any coding experience. Now, I do have to admit, related to the requirements for this course, it is a best practice that you already have some experience with cloud, for example, with Azure, AWS, or Google Cloud, that you have an experience with those concepts, with PowerShell, that you already have like a little bit of coding experience or understand what PowerShell is. So that are typically what the main, how do you say it, requirements are.
Do you present any details on using AI for malware analysis?
Very good question. So a specific use case is not in there related to the labs, but we do have slides covering like how you can analyze, for example, certain malware or certain techniques. Now, I do have to admit that there are dedicated courses related to incident response and malware analysis. Probably they will go more in depth, but we do tackle how you could leverage, for example, AI for these type of capabilities. So to answer your question very quickly, a little bit, but not very in depth or very detailed because it can go quite in depth related to malware analysis.
Yeah, we show, to add to that too, we show the automation playbook and workflow for that type of malware analysis using AI, using threat intelligence vendors. But like Jeroen said, we don't show how to break apart the malware and do the manual analysis. There's, forensic 508, other classes like that, lots of other classes that break that apart on the digital forensic side.
Would we be able to use this with Splunk SIEM and MS Defender?
Yes, of course. That's actually the entire part. So also a very good question there. So that's really the ideal scenario or the ideal outcome of our course is that you can leverage these concepts related to Splunk SIEM or related to MS Defender. I showcased you the integration of NAN. That is actually an integration with MS Defender. The reasoning, of course, from a lab environment, why aren't we using like then, for example, MS Defender or Splunk? That each student has his each own stable environment. And in that perspective, Splunk and Microsoft Defender, yeah, typically it's also license-based. So we're not using it from a lab perspective, but it's in there. Splunk SIEM is in there. Microsoft Defender is in there. So based on that, you will be able to translate those concepts into Splunk SIEM and Microsoft Defender. And even during the teach itself, especially with the live online and with the in-person teaches, we are always showcasing and asking like, okay, which type of environments are you working in? So that we can apply it towards, for example, products where we have experience with or that you have experience with. And Microsoft Defender is one of those products for me. Splunk SIEM, basic experience, but not in depth, but it's definitely out there.
One last question here before we wrap things up. Considering how quickly all of this tech is changing, do you have any advice about how we can stay reasonably informed about the latest changes in the AI world?
No, Jason, maybe you want to take up this question?
Yeah, that's a really good question. It's for me, I know I can't speak for Jeroen, but I know for me, like keeping up with the bleeding edge of all these changes, in all honesty, is like almost like a full-time job, just all the reading that I'm doing all the time. And it seems like there's a new AI tool every single week, or some type of new framework, agentic AI or tool. So I guess my best advice is to follow perhaps like a social media or RSS feed, really good on all the blogs, to get that information summarized and reading, and keeping up to date. Following the people that would you'll be able to get all that information. Jeroen is one of the people I'd recommend following. Um, LinkedIn, Twitter. What would you say, Jeroen? Something similar to that?
Yeah, I think one of the most important parts, we actually encounter this quite often during our course. So that's also, and I think Jason, one of the benefits that we have, we are using a plugin called OneTap, where we are updating like the links, like the new tool sets within every course run. So that's something we now adopted just to also discuss like the relevant tooling, what's out there. So we try to create them also from a SEC598 perspective, the community, to give you the latest and greatest, and what are some important updates, what are some important tools related to automation and AI, generative AI in that perspective. But indeed, a very good question, difficult to answer. But I have the same approach as you there as well, Jason. I'm following Jason, and I would definitely recommend to follow him as well.
Yeah, and just to add that too, like it's a curated list of the latest resources that are across AI and LLMs related to purple teaming. And we do track that on a one tab resource, and we constantly update that. So that is a really good idea. Thank you, everyone. It's been great. I really enjoyed yeah, not talking with you, but talking out to you, and then look forward to further chats on this.
Yeah, likewise from my perspective. I always get excited when we are talking about the course and when we are giving the course, especially with these new updates. And I really, again, this week or earlier today, I was working then on the workflows to see how easily it was translated into, for example, a different tool set. And I'm always that excited to showcase what's out there and to test and play around with. So, yeah, amazing to have you all here. And yeah, happy to chat and to hopefully see you in other webcasts, webinars, or teaches that we have coming up.